So for the next question, an object is being pushed on a smooth surface that has coefficient of kinetic friction 0.15. The object is 10 kilograms and the push force is 20 Newton. Find the acceleration of the object. So again, we're going to annotate this problem by underlining key information. So it's being pushed, right? So that means there is a force that pushing on it, an external force that pushing on it. So on the free body diagram, you will have to express this this force. Coefficient of kinetic friction. So coefficient of kinetic friction 0.15. So what it means is that mu k is 0.15. Object is 10 kilograms. So mass is 10 kilograms. The push force is 20 newtons. So F push is 20 newton. And they ask us to find the acceleration of the object. So once again, the first step is drawing the free body diagram. So I have this. Surface object here being pushed. So let's say that I'm going to say that being pushed from left to right. Okay. Then it has this weights acting on it. You have the normal force, and then the force of friction. All right. Okay, so this is the free body diagram, and you will need to identify the frame of reference. So I would have again. So I have O, X, and Y here. So that means that from left to right will be my positive direction for the horizontal, and from bottom to top up, right? That would be my positive direction for the vertical axis here. The next step is the second Newton's second law. So the Newton's second law will say that the sum of all the external forces would be equal to mass times acceleration. In this case, do we have acceleration? Yes, we do have acceleration. So in this case, acceleration is not equal to 0. Now, so what are the sum of these forces? We have, no, I'm just going to list it out, here. So we have F friction, we have normal force, so plus normal force, plus mg, plus F push, and remember that these are the vector forces, so remember their vector sign and equal to m times a. Okay. All right. So we're just going to do the same thing with the finding vector components. So in this case, I'll do the on OX first, right? On OX, so we will look at this one here, a horizontal line here. So F friction is actually going opposite the direction of OX, so it would be equal to what? Minus F friction. So minus F friction. Then the normal force is perpendicular to OX, so that this is equal to 0. So plus 0. Mg is going down perpendicular to OX, so Mg will be equal to 0, 2. And F push, the F push is on the same direction as with the OX here, right? So it will be what? Positive. So plus F push equals, now acceleration, because this object is being pushed, right? Being pushed from left to right, so the acceleration would be the same direction with the push force. So I would draw something like that. So the acceleration is similar on the same direction with the push force. So this would be equal to m times a. So that's what we have, right? And so we would have what we would have from this, we would have acceleration. Acceleration would be equal to F push, well, minus F friction plus F push divided by M, or just rewrite it. So that would be F push minus F friction divided by M. So I do have F push already, and it's 20 Newton. I have the mass, which is 10 kilograms. Now, what I need to find is the force of friction. All right. Now, force of friction, we know that so here you can write on the OY axis, right? So on the OY axis, you have what? You have that F friction here is what is perpendicular to OY, right? F friction going like this on the horizontal, and OY is the vertical. So these are perpendicular. So F friction will be equal to 0. Normal force going up, same direction with OY. So that would be plus N. Mg here is going down, parallel to OY but going down opposite direction, so that would be minus Mg. And F push is what? F push is again perpendicular to OY, so that would be equal to 0. So plus 0 equal to, now Ma, acceleration. Again, this acceleration is going horizontally, right, like this. And how is it compared to the OY? Is perpendicular to OY, right? So that would be equal to 0 too. So what you have is N equal to Mg. Well, this is a more complicated way of drawing, explaining it. But then, if you take a look at the free body diagram, you see that the normal force and weight here, they are pretty much what? Equal in magnitude, but opposite direction. So you can also conclude that immediately that N equal to Mg. This way, showing this is just to showcase that you understand the underlying principle of this problem. Okay. So now we have N equal to Mg. So then we have F friction would be equal to mu. And of course, we have mu k, right? Mu k, because the object's moving, times N, which is equal to mu times M times G. So that would be what? That would be 0.15 multiplied by M, which is 10 kilograms, and G would be equal to 9.8 meter per second square. Okay. So F friction would be equal to, alright, so let's do this. So this would be 0.15 times 10 times 9.8, which is 98, and that would be 14.7 Newton. We have F friction is 14.7 Newton. So then we would have acceleration would be what? Would be F push minus F friction divided by M. So F push is 20 Newton minus 14.7 Newton divided by mass, which is 10 kilograms. Okay. And so we have 20 Newton minus 14.7 Newton divided by 10 kilograms. So we would have 5.3 divided by 10, and that would be 0.53 meter per second square. So that would be the answer for this question. Alright, so 0.35, 0.53 meter per second square. And the sign would be positive, right? So it's being pushed from left to right, so it should be positive.